keep it open for the AMAs course. Are we live? We are live. Are we recording? We are not yet recording, so we should record this to the cloud.
Hello, hello.
Yeah, should be good. Cool. All right. Just gonna double check, make sure we're actually live here, and we are. What's up, everybody? How's it going? So I'm here with Anish Shah from Weights and Biases. Uh, Anish, tell us a little bit about yourself, a little bit about your background, and what it is that you do at Weights and Biases.
Yeah, sure, of course. So hello, everyone. I'm Anish. So I used to work at SAP doing a lot of different work around data. So different teams within the data space. So from analyst to scientist to engineer to then making my way to machine learning engineer slash MLOps person, where infrastructure really became like my bread and butter, what I really love to build and look at. And I started off actually as a university student out at Temple University in Philadelphia.
So how'd you get into like the MLOps part? Like, were you confronted with challenges like trying to deploy models, and what made you want to like tackle that head on?
Yeah, so I was working as an internal startup within SAP, and so I was the only data scientist that naturally became an ML product. So as we realized, when you become an ML product with one customer, it's pretty easy to deploy. But when you start to have tens to hundreds, you got to rethink your complete framework for deploying it. So at that specific company, we're working with recommendation systems, and so we would use an embedding model to, based on the specific topic or industry of this company that was our customer, we would have specific ways to embed them their text of their job descriptions to make it easier for their for prospective employees or candidates to go in and find the most relevant job. So it caused us to have a really big problem of how do we actually serve these models that are pretty unique to each customer in a way. And so you just have to upskill, or else your ML algorithm just never sees the light of day.
So speaking of upskilling, like, what was your kind of expertise? Were you like more of a model builder? Were you always good at software engineering? Like prior to getting into MLOps, like what was your baseline skill set that you had to upskill on?
So I think very early in my career at university, I started focusing specifically around software engineering in ML. So I was kind of lucky in that part. But will I say I'm the best software engineer? Probably not. There's definitely ways to improve for all of us. But I do think I spent a lot of time understanding the tools and the needs of ML folks in general. So when our team started to scale and we added more ML practitioners to our team, it started to become a problem of how do we productively use all of our employees, which actually does come down to almost ML ops because if there's a lot of double work done and a lot of work that cannot be deployed or used by customers, then it just becomes work done for the sake of no one.
Yeah, yeah. Um, so how'd you get into weights and biases? Like, was there anything in between SAP and weights and biases? What, I guess maybe describe your current role at weights and biases and kind of like how'd you get into that?
Yeah, of course. So previous to this, to joining Weights and Biases, I spent some time at a boot camp within called Fourth Brain, which is a subsidiary of Deep Learning AI, and they had a specific first class around MLOps. And so in that class, we learned a lot about Docker, Kubernetes, and scaling out LLM models, well, sorry, models, and specifically large language ones in that case. But yes, models for deployment. And then one of the tools that stuck out to me was Weights and Biases, where I instantly fell in love with the API and just kind of like the workflow and tooling that they were building, and felt I could have something to serve out there. And so put my hat into the ring and moved on to my next role, which is here.
And your role is kind of like content creator, educator, but then also like engineering as well. Were you like always kind of a content creator of sorts? I mean, you have like kind of that educator background at Fourth Brain, right? Because they do a lot of educational content, but were you always writing blogs and stuff like that on the side?
Yeah, I think I was naturally toying around with all these different tools. So I never actually formally, I think, wrote blog posts. Unfortunately, I did spend a lot of time though giving feedback, I believe, to a lot of ML tools that I thought were prospectively interesting. And then within Weights and Biases specifically, I found myself naturally collaborating with a lot of different folks around these tools, and just from there, these tools I started building with became the tools I wanted to write about.
And so Weights and Biases, they're known for a number of awesome things, but experiment management, that's like a huge part of it, the core product. I was wondering if you could share any kind of frameworks or guardrails for experimenting with deep learning models. How do you kind of think about that?
Yeah, so I would definitely say that within weights and biases, that's an existential question we always ask ourselves, and that's why we come to you guys in the community. And so, if you ever find anything that you find different, please let us know. We'd love to expand upon that. But I would say that when training deep learning models, I think that a very important part is actually understanding how the end user may perceive what you're working with. So, for instance, if you're working with internal models, then you have to make sure that your processes around making sure that you validate and have a good framework to ensure that when you make improvements to your model, they get properly propagated to whoever may want to use it. And so in our case, not only is it experimentation, but it's understanding why you're experimenting in the first place. And so when you're experimenting, I find that it's very important to really keep track and audit yourself all of the different parts of your model and your modeling experience. Because if you're making if at any point you find yourself losing insight, that's not lost to yourself only. That's lost to everyone downstream who's really working with that product. And I find that like, and one thing I learned early in my career was what may have been a small toy model that you thought wouldn't be used for often may become the basis of what is actually your core product functionality. And so having that initial thought process around how to scale out your one tiny model into a bigger team of models or a bigger team of employees working with this model, I think that's like a very important to think about in your experimentation.
Can we kind of walk through like a maybe a hypothetical scenario just kind of to see how you think about uh, approaching this? Like, let's just say we're working with basic task of image classification, right? We want to take some pre-trained model off the shelf, and then we want to, fine tune it on our own data. What are the considerations that we should make from both from like I guess like managing the data perspective, managing your hyperparameters, and kind of logging and things like that. What are some best practices you can share with the audience?
Yeah, of course. So I do think it starts with the data itself. So one thing that we can never escape is that good data quality matters in part of your whole training process. If you have bad data, your model's not going to do well. You can probably create interesting architectures, find the right parameters, but the moment you make any tweaks, then you have to redo this whole process in a very painstaking way. So I think one thing is to ensure that you have a clear understanding of not only your data, but also an understanding of how that data changes over time and how that affects your model and model performance. And so you may instrument and use any form of experimentation software. So do recommend with devices. But regardless, whatever you use to track your experiments, you want to understand that this data was used in the context of these configurations and these hyperparameters so that for when your model, in this, for instance, this image classification task, you want to ensure that whatever output loss or accuracy that you're measuring, you have that full lineage backwards to see, hey, this specific subset of data with these different two knobs is what causes output. So that when you actually do run, you have this nice trained model, you can properly put it into an evaluation suite and actually qualitatively and quantitatively say this model is doing well on out of sample data set. And then from there, you can start to build out the rest of infrastructure. And so I would say, like at least from an experimentation perspective, having that full pipeline, which is pretty standard of data curation and understanding, so like EDA, model training and model evaluation never changes, even for deep learning, but ensuring that you have that full context with you. So like also in this case of image classification, if you are using bounding boxes or annotations, having that in context with any summary values that you care about, any metadata, is extremely important. So if that matters to you for your end user or your application, ensure that's part of your training process too. Because there's now very modern ways to pull out very representative examples during training and evaluation and see for yourself the truth of what your model is doing.
And uh, we're going to delve into LLMs a little bit more, but I'm just curious, like kind of something to simmer on until we get there. Does this overall process change now when we swap out the task from image classification to maybe working with language models?
So yeah, I do think language models has its own little unsolved problem in a way, which is how do you properly quantitatively analyze the outputs of large language models. So I think for images, it's way easier to say things around pixel densities or have like annotations that properly see overlap over certain classes, for instance. But with large language models and the output of language itself, it's hard to say how well language is because it is because of how it's trained with kind of this mixed bag of different vernacular, but also like classical writing. It's almost like these large language models, which we see with this kind of like latent emergent understanding that it has or reasoning, that it can be really easy to transform how it speaks, kind of how we speak normally. And so to quantitatively, sorry, he's saying that, quantitatively analyze that, that becomes its own different problem. And so I would say this task of evaluating large language models is a very different one in this deep learning space now that I think has become more prevalent. I think it's always been a problem in NLP generally, but I think now it's becoming much more of a scrutinization with a lot of ethical questions behind the scenes of the usage with these large language models and what it can do for information generally.
I see a lot of like smack talk around the term LLM ops. People are like, isn't that just ML ops? Like, I'm curious about your perspective. Like, is LLM ops just ML ops, or should we be thinking about this completely differently?
So I think it is a almost like a subsection of it. I think there's a lot of similarities between ML ops and LLM ops, but I do think that the main considerations that one focuses on with LLMs for their operations is very different. So, like for instance, latency and token usage is like a new concept that becomes really important. Where in general we do care about like the hardware utilization of other models, such as the ones used in image processing and such. But for LLMs, a lot of times you're also considering how does a large volume of data affect the actual latency for my deployed model. So let's say you're using one GPT from a provider, or like Anthropics or Cohere's, or you're deploying your own. The actual utilization has a lot more scrutiny because you can't take 2 minutes to give a chatbot response. In our world of information that moves so quickly, most users and most realistic use cases around LMs are are focusing more heavily on quickness. As something like an image processing one, while we do focus on quickness, there's almost an understanding by users that this is already very cool, interesting tech. The scary part about LMs is that most users, a good LM usage is one that is seamless, where your user doesn't even know or try to truly understand that LMs are being used behind the scenes, and that requires a lot of human level latency and human level consideration. So to bring it back to LLMOps question, I think that there's a lot of different focuses about specifically around speed, latency, and even like the deployment of your model itself. So how does it affect when you do make changes to the models, where a small tweak and a version of a model makes significant changes to your underlying prompts and usage that changes very rapidly with the usage of these models.
So let's go a little bit deeper onto LLMs. Kind of start from maybe uh, the high level. Um, can you give us kind of a overview? Can you map the landscape of LLMs for us?
Yeah, of course. So I definitely think that we have like the GPTs of the world that made it very interesting in the beginning of NLP research. So I think that we have like standard models and autoregressive models that existed generally that were able to generate text and then use that for really useful use cases. But I think that we're finally at the time of like chatbot level ones. And so from the beginning we had like GPT ones, GPT twos, which had a lot less parameters and were a lot more manageable to run on like consumer GPUs. Now we're running to this world where if you're not like the largest organizations like the Googles, the Metas, etc. of the world, where you have access to large quantities of and clusters of GPUs, then that's where we start to see this growth of the GPT 3s, 3.5s, and GPT 4s of the world, where we saw that the scaling laws in both in data parameters and also just the amount of units stuffed into the architecture of these models have actually caused the growth of these models in an accuracy perspective. And so seeing that simply right now we're in a world where throwing more hardware at these models has sufficiently worked to increase the accuracy of it, that's where we start to see a change in the actual largeness of these models. Like back in the day, like a 127 million parameter model was considered big. Now we're talking about, we don't even know for GPT-4, but probably billions of parameters behind the scenes. And so distributing that over, so we see now that we're taking models and we're distributing them over data, over tensors, and over architectures in such performant ways. And so one thing that's very interesting is that not only are we looking at increasing the size of these models, but also increasing the ways we can split up these models so we can actually efficiently do them on smaller consumer GPUs or quantizing them in ways that we can do efficient training and do things like PFT learning and whatnot.
Can we talk a little bit about scaling laws?
Mhm.
As Chinchilla is like the one that I'm
Yeah.
most familiar with. Can you kind of, uh, and when I say most familiar, I mean I've heard of it. So can you give us an overview of I guess within the context of LLMs, like what is a scaling law, and are there like multiple different scaling laws out there? Yeah.
Yeah, I think that there's still a lot of investigation around like what is actually behind the scenes in a way, allowing the just the ability to throw more compute and essentially grow just naively growing the parameter size and the data size of these models. Um, we're still, I think, a lot of rules around that to see why it works so well. But a scaling law is essentially like Moore's law, where eventually we would imagine a point where any hardware we create will have not as many returns because it reaches a point where there's always such a smallness of size that one can create to have efficient performance for usage in like CPUs or GPUs or etc. But right now, I would say we're still in a space where we can make them smaller, make them use more efficient materials for at least the hardware perspective. And so, because we live in this world, we're able to take this hardware like marvel that we have and use that in context of large language models and just say, let's just crank up the amount of parameters needed and the amount of data. And I think that there is, I don't remember the rule off the top of my head, but I think there is a crossover of how much more data for how many parameters can exist. But essentially, when you reach that sweet spot of both, I think that with being able to just naively throw that on this hardware is what's allowing these scaling laws to be proven as correct.
And you mentioned earlier parameter efficient ways. What does parameter efficiency even mean in this context?
Yeah, I would say so. I'm not the most expert on these different tactics, but I'll definitely say a big part of it is understanding how to cleverly and uniquely utilize the transformer style architectures we have, and be able to determine at what points are we able to scale down and scale up the sizing of these different units, and be able to pretty much compute the similar style of um, like use the data in a similar style of training as the original forms, but still be able to take the full advantage of the normal back propagation style techniques that we see now. Where I do think in the future we'll have this usage of like forward models that was mentioned earlier in the year, I think by I forget which vision.
Hinton, yeah,
Hinton
Hinton,
mentioned
yeah.
it, but I think right now because we start living in the back propagation world, there are still ways to cleverly downsize a lot of different aspects or freeze different aspects of your model, such that you can only tune the important parts and still be able to do that in a very consumer friendly way.
There's so many like language models out there, right? There's obviously OpenAI's models, Anthropic's, like there's open source models. Like how do I choose which one I should use for my use case?
So I'd definitely say what that's a very difficult question to answer because of how quickly the space is moving. I think within the last 3 weeks, there have already been a larger growth of models. Like I think of almost a month ago was only when Llama was first introduced. That became like the newest backbone for all of these open source models being built out now. And so we see things such as Vicuna, Falcon, GPT for all, MPT, MPT, um, I forget the name, acronyms, a lot of them. I think that it comes down to understanding your use case's important aspects. So what I mean by that is what does latency look like for you and what restrictions do you have from a hardware perspective? Because a lot of these models have different sizes that may be useful for your specific task at a certain point. But I think that understanding how you can efficiently deploy that for your own use case is important in itself. So if you find out that GPT for all, a large size, works well for your use case, but is not useful from a perspective of the end user where it takes way too long or you're burning money to the cloud provider spinning up the large cluster of GPUs needed to serve it, then I think you need to go back to the drawing board. And I think that there are a lot of interesting tools like the OpenLM leaderboard, which tells you across a lot of different metrics and different tasks how well it does and has almost like a stack ranking for that. I think doing a mixture of understanding the stack rank of your class of task for a specific model alongside your realistic restrictions for your deployment or usage of it, I think that's the two important considerations that need to be made.
And can you define stack rank for the audience?
Yeah, sure. So there's this concept called elo rating. So for the gamers of the world out there, it may be a familiar term for competitive gaming. Essentially, it's a way to create a score based on a lot of different metrics for your model. So in this case, there's a variety of tasks and data sets that are thrown into all of the modern LMs that I believe is hosted on Hugging Face right now. And you can go into that list, and it provides an elo rating for these models. So essentially, in effect, looking at all the metrics, which model does the best. But at the same time, you can go ahead and choose the for whatever task or whatever data set matters. You can sort by and find the metric that matters for a data set. And so, for instance, if you're using a healthcare one, you can see directly for a toy healthcare data set or one of the data sets popularly hosted for evaluation. You can see that score in context of these other open source LLM models.
So the way that we interact with these language models is prompting, and there's like so many different ways of prompting. I could just like plain English just tell it to do something, but there's been this like kind of emergence of methods, right? Like
Mm-hmm.
tree of thoughts, chain of thoughts, I think, right?
Mm-hmm.
All these different ways. Can you kind of give us an overview of the various methods of prompting and maybe double click on like the one that you have found to be most effective?
Yeah, sure. So I think you already hinted on one that's really popular, which is this chain of thought prompting, where essentially by defining to your prompt, to your chain, your agent, your ChatGPT, whatever you're using, defining the asking it directly that, hey, here's an example of a chain of thought reasoning, where you say, hey, for this question, here are the intermediate steps in my brain I'm taking to actually solve a problem. So, like for instance, in the case of math, you show off explicitly PEMDAS, and that would be considered a chain of thought reasoning. But transparently, these models aren't doing math. I think it's a good analogy to understand what underlying steps are needed to actually go from question to answer. And so by explicitly writing these steps as an example to your model, the model will be able to understand when given that act at the very pretty much an empty colon saying what is your intermediate thoughts at the very end of your prompt or question. It'll be able to take that question that you have and break down the intermediate thought process to solve the specific question being asked. So in this case, it could be asking, what is the weather in Vancouver today? And so behind the scenes, it may go, okay, I need to first find out where Vancouver is. Then I need to go and maybe use an API or make a decision about how to find the weather of or the temperature of this location, and then go and perform that action and return that back to you in a human readable way. So for us, that happens automatically. But behind the scenes, there's actually a lot of like we talked about a lot of different steps that went behind the scenes to actually get that answer. And so that's almost a way to peek into the black box of these large language models and understand what it's actually doing to elicit the answer that you care about and are going to be using for yourself or your applications.
What are your thoughts on the term prompt engineer? It gets a lot of pushback from like capital E
Mm-hmm.
engineers, but like yeah. What are your thoughts on that? And like, what is prompt engineering? Like, what does that mean to you?
So I would say pretty much if you're a programmer, you're probably in a way prompt engineering. So in this case, a Google search in a way is like a prompt. You're writing a very specific syntax to find information that you care about, but then you're doing the actual action of reading that specific article or page and then eliciting a response to the implicit question that was in your brain as you initially asked that question to the search engine. The difference here is that I do think that prompt engineering has a lot more heuristics and a lot more growth opportunity in the sense of how one needs to think about prompts. Because one problem with prompting is that prompts vary between model, and they vary between model version, and they vary between model architecture. So there's multiple dimensions that you have to worry about for your prompts. So let's say you're using GPT-4 at one case. One day you're going to have a large collection of all these prompts that work really well for your application for GPT-4, but now comes the time of GPT-5. So do you know what you're doing? You're going back and you're debugging all of your prompts with these new architectures and models and model versions to truly understand if it's going to be working for your application, which in a way is engineering.
Hmm.
And so I won't give it any harshness here, but I do think that prompt engineering also has a different workflow. And so to like kind of bring it back to this LLMOps thing that we mentioned earlier, there is this kind of perspective of how does one like save efficient prompts? How does one create a proper framework to qualitatively and quantitatively analyze prompts in context of these different three different dimensions I kind of mentioned? And even more so, how does one compare prompts to each other in this kind of evaluation framework? And also, like, what changes does a person need to make to prompts so that it can properly utilize the latest and greatest prompt engineering tactics? So I think that there are also like a lot of different techniques that haven't been talked about that are still being actively investigated for.
So what about like prompt versioning? How do we do that? Is it just like simply doing like we would check in code on GitHub, or is there a better way to do this? Like weights and biases help with that at all?
So right now we are working very heavily on creating a good way to version prompts. And I'm gonna say transparently, I don't think that there has been a really good answer to that yet. I think that the thing is, people love these applications, these large language model applications, because of how conversational and how humanistic it feels. It's pretty much you having a conversation with yourself and reading some information and going, this is correct or this is not correct, and making adjustments a little bit more dynamically on the fly. And so I think that there has to be almost a way to directly keep the human in the loop during these processes when you version between models and save them in a way that it's actually more comfortable to refer back to previous prompts that may have worked better than anything you're trying now. So I think that there's almost this discussion that needs to be made about how does one actually do like this comparison between prompts in a way that you can automatically in like almost like a node like structure like go back and understand these permutations in the language I use are actually what's causing these changes in my prompts. And so I think the versioning question is not less so about how to actually save these versions of prompts, but how do you actually save them in a way that's meaningful for comparison and meaningful for the insight for how to actually make adjustments to these prompts. So the short answer for the weights and biases perspective is we're thinking about it really heavily, and I think that for all of you using GPT-like applications, that's something you should all consider too, because it's very easy to blindly prompt into your application and hope that it sticks, but it's very difficult to make a very safe and ethical application that's going to be able to deal with any permutations by end users and permutations to the changes in the models and your prompts itself.
So where do frameworks like LangChain or Llama Index fit into this world, for lack of a better word, of language models?
Yeah, that's a great question. So I would say that we live in this world of essentially, at least in the large language model space, a question of tool or no tool in a way. So LangChain is a very comfortable experience to get instantly started with applications that have for large language models and to build in a lot of different functionality that you'd be currently doing. Like for instance, one problem with large language models now is that you have to ensure that it fits within a token limit, which will be the chagrin of most people working with these models. So now we get to a point of using these interesting tools like vector databases to inject information dynamically such that we can utilize the reasoning of these large language models, but also have current context that doesn't exist in the pre-trained data set of the underlying model that serves this GPT-like application. And so, uh, in essence, a LangChain builds a lot of abstracts a lot of that stuff away. You have a database that you're currently using, make it a 2 lines of code as opposed to maybe 5 or 6 lines of code where you may spin up SQL Alchemy and actually connect to a database. LangChain will just say, give us a URL, we'll do the SQL Alchemy stuff behind the scenes and throw in the text or SQL for you. But at the same time, as the reason there's a question of tool versus no tool, with no tools, you have infinite flexibility to build out your application. And so when you do have start to really enter the space of custom changes within LangChain, you'd have to make more changes on top of the base units of classes or modules that exist and extend upon that, as opposed to just simply building out your own collection of tools that you would use internally. So me, I love LangChain. We have a one-line integration with LangChain for good reason. It's just very comfortable development experience. But at the same time, as you scale out, you may find that with custom use cases, building your own tooling just may make more sense as it removes a lot of the bloatware that LangChain may have that you may not even want to use or may have been feel compelled to use as it exists as a module within that ecosystem.
And have you experimented with Llama Index at all, or are you?
Yeah, so we also have a integration that I think recently released on Llama Index, and I think that Llama Index has this kind of approach where it does one specific thing really well, which is that it does that connection between vector store and the prompting and discussion layer with these GPT-like applications really well. And so that's where I think the difference between like LangChain and Llama Index exists is that LangChain tries to go for a more ecosystem approach, where I think Llama Index just has a really good approach of strongly connecting with these IR retrieval methods that you are currently going to be using and ensure that that stays as the forefront of unit in your applications. So I think that it lives in almost like a happy place in between the two, where a lot of times you're not going to escape using some sort of IR retrieval service to inject in modern information for large language model usage. And so, if that's the case, why not make that one simple piece, that abstracted piece, really easy to use, and then from there you can start to build out all these interesting applications.
And just for clarification, IR information retrieval,
Yeah.
and so something that comes up often in the same breath, almost retrieval augmented generation. Can you kind of give the audience an overview of what that is?
Yeah, so I'm not sure if that's the specific phrase. I'm sorry, I'm like a little bit
Yeah.
bad with some of the acronyms or phrasing nowadays. But I do believe that that's when you use an external knowledge base, so like a data set, a database, vector store, a flat file, etc., to grab the latest information for your application. So let's say, for instance, you have a fashion GPT, we'll call it, which will try to like just make decisions about the outfit you should wear for the day. It may with the current data set, it'll only use items that were in the data set from like 2021. The problem is that either those items are discontinued or out of fashion already. So you may need to do instead is directly go ahead and grab or curate your own database of all of these different items and ensure that you save them in a way that's very easy to grab in context of a question. So if it says, hey, I want to wear a sundress today because it's a beautiful weather out and the sun's out right now, then you want to ensure that the description of your articles of clothing or the way you store the metadata around the actual items you may want to sell, um, ensure that it makes it very easy to say, oh, sundress, that means dresses generally for with using certain materials. Let's grab those out of my database, hand it over to my model and say, okay, you are smart enough to know that there are fashion trends that exist and you wear these certain types of clothing for certain weather situations, which is stored natively as part of its underlying reasoning process from the large language model. And now you're just giving it more knowledge to say, okay, but now your data is out of date, and you know that. So use this in this very modern pieces of information to now make a decision, and it does a really good job of that. It's like we as humans almost in a way where we're told, oh, that thing is updated and made changes. You go, okay, it's the changes have been made. Let's start to use that as like the main forefront of my thought process when I start to talk about this specific topic.
And we mentioned a couple times here vector stores, vector databases. Um, as a kind of general concept to explain to the audience, like what are these vector stores? Yeah.
Yeah, great question. So I would say a vector store, in essence, for those of you familiar with storing embedded models and whatnot, what you would have is you'd have a essentially what you do is you would use an underlying pre-trained model or whatever model is, that matters, and takes a latent representation for whatever information you're passing through. So for simplicity's sake, we're going to say we're only working with language, but there are ways to also use vector databases to store images or pretty much any modality of information. But in this case, let's say for storybooks, what you may want to do is you have a whole library of information. And instead of storing the raw text of all of these books, which makes it kind of difficult to search over because you may need to use standard search tactics such as uh, finding the most related phrases based on direct word to word match. Instead, you use the semantic underlying meaning of the words nested in these books to actually do the search. So in this way, what you're doing is you're transforming that text into a numeric form and using that numeric form to be the mechanism in which you find the information. So use something like cosine similarity to do that. So as an example, you may have a question saying, I want to learn more about Game of Thrones, for instance. So obviously, you can just what you can directly do is use Game of Thrones, and do that and search through that specific phrase and research out from your a standard database all of the different articles that say the word Game of Thrones and sort it by those that say it the most. But let's say that a lot of articles in your library are actually like are newspaper pieces talking about Game of Thrones, but it may not be the book Game of Thrones, as it may not directly use that phrase as much as these other articles do. So instead, what you might want to do is have a better way to say, okay, I want something that is also um, so instead, what you might do is like you transform that specific question into a numeric form such that you can use something like a distance comparison, so like cosine similarity, over these vectors that stored all of the Game of Thrones books. And instead, what it'll do is it'll use that underlying the underlying meaning of the words that were translated into a numeric form to actually retrieve the most relevant novel here, where the relevance comes from the actual semantic meaning stored in this numeric transformation done.
And so that's so much good information. Hope you guys are taking notes. If not, this is recorded, so go back and take notes, or transcribe this using Whisper and build a QA bot with the transcript. But let's talk about productionizing language models. So, uh, do you notice any themes that come up in terms of challenges that companies face when trying to productionize language models?
Yeah, so I would definitely say right now, agents are super interesting and very fun. So, for in this case, what an agent is essentially a reasoning engine that uses a large language model as almost the brain of this reasoning engine, but may have access to the ability to go ahead and use tools. So, tools here can be access to external APIs, connection to databases, or accessing vector stores to grab the latest relevant information for a given query. And so agents have had a lot of interesting research papers that exist where there was one where they almost created a simulated town of people where all of these agents were just kind of given descriptions about themselves and a system message saying, hey, you live in this town and you are a person with this kind of background. And essentially, this agent town was able to properly communicate with each other and essentially create their own little society. And so it is a really cool, but at the same time, from a consumer application perspective, there's a lot of scariness that also happens behind the scene. So there's a lot of ways to fuck a better phrase, jailbreak and also negatively use these agents so that you can use it for malicious purposes. So from not even ethics perspective, but also from a misinformation perspective. And so I would say agents right now are very fragile in that perspective, where even the best of prompts can still be taken advantage of in very specific ways. And with agents, because you're using using as more of an underlying reasoning engine, there's a lot less flexibility on how to control and constrain agents. So as a result, agents become scary right now, and I've found a lot of difficulty in the use case for applications and businesses. But I'll say things such as chains, which is a way of stringing together collections of usage or prompts, pre-curated prompts for your LM application. So instead of saying LM application is this agent that's reasoning and making a decision about how to solve this question, what you do is as a prompt engineer is you say, oh, this question can be broken down into 3 different steps, and I'll use the LM to solve these 3 different steps in different way by prescribing a pre-written prompt that will solve it for this specific perspective. So in our case of like a QA bot, for instance, what you may do is say you may only answer questions given information from this database, and you may not stray at all from this answer. So an agent, that's very hard to do and form fit. But when you have only one step in your LM process, or I guess in this case, this chain that has explicit rules about what it can and cannot do, it's very easy to debug that. You can go in and say, okay, the output of this one specific step in this process of thinking as outputting something that's very easy or brittle to break in terms of a very harmful prompt, or also too just has been giving really weird answers. So let's go and focus on and hone in on this one aspect of this prompt. So it makes prompt engineering a way more valid method for experimentation as opposed to hoping as you would do in an agent perspective.
Awesome. Thank you very much. I'll see if there's any questions coming in on LinkedIn, which there's not. Uh, LinkedIn has been doing a horrible job of pushing my post to people. Must be because of this URL there. But yeah, if anybody has questions, let me know. We're opening it up for questions, trying to get to the live chat there. No questions coming in. Dude, that was such a good like overview of like the landscape and everything. I really appreciate you taking time to chat with us. If people wanted to connect with you, where could they find you online?
Yeah, I would say you can find me on LinkedIn. So Anish Shah. I think I have something around weights and biases in my bio. Or generally, you can go to weights and biases. So wandb.ai/fc. That's our blogging platform. So we can go ahead. That's where we publish a lot of interesting insight regarding large language models, images, 3D objects, kind of pretty much the latest tactics and MLOps thought process. Or our Discord too. So wandb.me/Discord.
Do you guys host like live events or anything in your Discord? As like things like that?
Yeah, we have a very bustling community out there. So our community managers do a lot of different events where they may do hackathons, they may do events where we like work together and discuss certain things, decide on webinars, etc., etc. So if you guys have interesting events that you'd like to propose that we can help with, we'd love to do it.
Awesome. Well, thank you very much for coming, Anish. I appreciate you taking time to join me. And cheers, everybody. Bye.
Have a nice one.